Hi, in this lecture, I'm going to talk a little bit about how to use the real-time software in the Cosmic Control Systems Laboratory called QuaRC, which is QuaRC Real-Time Control is what it stands for. So this is what we're going to be looking at here. So I'm going to cover the basics of QuaRC, which is an extension of Simulink. So we're going to talk about designing a Simulink model with QuaRC, setting up the real-time environment in QuaRC, using scopes, building the executable, and then running the real-time code. Now the version these slides were made on an older version than we currently have. So I didn't want to change the slide because all the steps are still the same. And so if you happen to be in a situation where you're using an older version, then you'll know what to do. At the end, I'll actually show a video demonstration of all of the steps. So you'll see what it looks like in the most recent version. All right. So first, you need to make sure that QuaRC is installed in your computer. You can do that by doing help QuaRC. You would then fire up the Simulink library browser to create a new document. And so you would then locate the HIL initialize block under the QuaRC targets, data acquisition, generic configuration. So again, I'll show you what this looks like, but you need to find this block. So this block looks a little different in the recent version than it does in this version I'm going to show you. So this is where you would find it. You will double click on that block and change the board type to Q4. So by default it comes up with Q8. So you'll need to actually move the scroll bar up to get to Q4. All right. Then you'll build your diagram. You'll need to choose the appropriate data acquisition blocks from the library. So generally we're going to go to immediate I/O, and then there are some of the blocks we can use like HIL read and so forth. HIL write. So those are some of the blocks that we will use. Then so here I've chosen HIL write analog, HIL read encoder. Okay, and so I have created a subsystem such that basically I can use this kind of block, subsystem block, to create like a motor block. So the motor block, you would write an analog voltage out to the motor. You would then read the encoder, and then this would convert, if you have an encoder with 500 pulses per revolution, this will convert those 500 pulses per revolution into degrees. Okay, so it converts the encoder signal into degrees. And so the input is voltage, output is degrees. So over here in the analog write, I would use channel 0. And the analog read, I would choose, again, channel 0, depending on where you physically hook it up onto the board, onto the breakout board for the Q4. You can also specify a sample time here. So here it grabs a sample time. So this is the default variable that QuaRC defines, but you can specify your own value in here in each of these cases. So I recommend for EE476 that you would actually specify these values. For EE314, you would just go ahead and leave the default values there. So in creating a Simulink QuaRC model, again, you would create the rest of your Simulink model, and you may need to use rate transition blocks at various points. And you will actually see where you need to do these. If you need to do them, you will see where to do them when you actually build, because it'll tell you that there's an error. Okay, it'll tell you that you need a rate transition block between this block and this block, and so. And again, I use subsystems to help clean up the diagram. So here's an example system that I've put together. I have some excitation signal that I've created somehow with some combination of blocks like sinusoids and so forth, steps. So here's that subsystem block that I had where the input was voltage, the output was encoder position, and I'm putting that output into a mux that goes into a scope, and I'm going to compare the input and the output. Notice that in order to compare the input and the output, I needed to use a rate transition block, and you can find that under signals, signal properties. That rate transition block. You would then set, let's see, in the Simulink window, there's an option to, it says normal. You need to change that setting to external, and then you need to set the stop time. In older versions of Simulink, you actually need to go in and make some of these changes: fixed steps, discrete solver, default fundamental sample time. I think now the fundamental sample time, the default is 0.002. So anyway, that's generally fast enough. So in terms of what it looks like, there's actually, so it normally says normal, so you need to actually select this drop-down menu and select external. Then set the stop time. The default is infinity. Okay, so I set it to be something else, 20 seconds. Because again, if you're going to be capturing data, you don't want to capture infinite amount of data. You generally want to run your experiment for a fixed amount of time. So these are changing some of those parameters I mentioned. Again, in the more recent versions of Simulink and QuaRC, a lot of these things are set for you, like this. These are set for you, so you don't need to worry about them. In the scope now, in working with the scope, double-clicking on it, I can choose the menu. So in the more recent version, instead of having a little menu icon, it has what looks like a gear icon. We'll see that when I show you the video, but so that's what we have. And these are some of the things we would change. We would click on data history. We would uncheck this option. We would check this option and put in a variable name here. And then we would choose this option. So that way, what's going to happen is when you run your simulation, the result of your simulation, the data, is going to go into an array named this. The first column of that array is the time vector. And then if you have multiple inputs coming into that, like through a multiplexer, then each column will follow that first column. Okay, so that's how you can extract the data and use that to generate a nice plot for printing. Generally, the scope doesn't print very well. I don't know why they haven't ever made that very simple, but anyway. So these are the options you would choose in working with the scopes. Also, in working with scopes, by default, the number of values that it's going to display is 1,000 or 5,000, depending on the version that you have. So you'll need to actually go to this. So in the former version, it said tools. In the newer version, it says code, and you would look for this this option, external mode control panel. Okay, and then you would click on the signals and triggering, again, working with scopes. And then you would change the value, duration. So instead of 5,000 values, here I put 200,000. Okay, then you hit close, and that will apply it, and then close the other menu. Okay, then you need to build. So you can either do that from the QuaRC menu, or there's a button, or you used to be able to hit Control B. I don't know if it still works or not. That's the keystroke option. And so when you hit Control B, it does a lot of stuff. It does compiling, linking. It does a lot of stuff. Okay. So in the older version, it would actually display all that stuff. Stuff would all go by on the screen. Okay. A lot of stuff going on. And then at the end, it would say something like this: the model has been downloaded to target. Blah blah blah. So in the modern version, instead of having this displayed in the main command window, this will come up on a separate window if you want to look at it. You don't have to look at it, but if you want to look at it, you can. If there's an error, that window will automatically come up and it'll display the errors. So if you didn't connect something properly, it'll come up and it'll display those errors. Now, in terms of running the real-time code, there are a couple things you need to do. First thing you need to do is connect to target. In the more recent version, this looks different. So I'll show you what that looks like. But this is what it looks like for now. So the first thing you need to do is connect to target. When you connect to target, then you can hit the, after you've connected to target, then you hit the little play button and your simulation will run. If you want to stop your simulation in the middle, you can press the stop button. Otherwise, you can just let it run until the final time, and then it'll stop itself. Okay, so after you run the simulation, you should find in the MATLAB Workspace, you should find the variable name that you put into the scopes settings. Okay, so now you need to be careful because there are some blocks, particularly real-time Windows target blocks, that will result in weird errors. So you can't just use any block with QuaRC in the real-time setting. So you need to be careful. The real-time Windows target are particularly susceptible to problems. All right, well, let's take a look now and at a little demo of how to set all this up with the most recent version of QuaRC. All right, so here we are in MATLAB. I'm now going to go to Home, and then I'm going to click on the Simulink library and open a new document. Now I'm going to go over here to the QuaRC targets, data acquisition generic configuration, and choose the HIL initialize block. Double clicking on that, it's going to bring up this menu, and notice that Q8 is default. I choose Q4 and click OK. So that's the first thing I need to do. Next, I'm going to go to immediate I/O, and I'm going to select HIL read. There are a number of ones I could choose. HIL read is one, and then I'm going to do HIL write over here. Okay, drag that over. So just place these here, and then double click, and I can change now which channel I want to use. So if I'm going to use channel 0 here, so notice if I don't want to use any analog input or write to any analog, I can put closed square brackets. Okay. Otherwise, I'll put the analog channel in that I want. Okay. And I'm going to use a motor, so I don't need an analog channel. So I'm going to make that empty brackets, and I'm going to use encoder number 0. Okay, because I'm going to use a motor. I'm going to connect up a motor externally to this. For a source, I'm going to throw in a sine wave here, attach a sine wave. For a sync, I'm going to go in here and I'm going to choose a scope. Okay, I'm going to connect up my scope now. So, open up my scope. I go to Settings, History, uncheck that, check that, put in the variable name I want to use. So again, a lot of this is the same as I've shown you before. Check Array, then click OK. Then, so that's good to go at this point. All right. Now I'm going to go to the sine wave, and I can see those parameters. I'm going to change the stop time. I'm going to set it to be 25 seconds, put it in external mode. So notice when I put it in external mode, I get a different menu. Then I go here to Code, External Mode Control Panel, Signals and Triggering. Okay, and here's the value. Over here I need to change. I'm going to put 100,000 in there. Okay, just more than 5,000. Okay, and then so I'm good to go. I'm going to save it. In this case, I'm going to call it try 2. And then I'm going to go ahead and build. So there's the build button. And so when it pulls up the MATLAB command window, I'm going to go back over here to this window, click on it, and notice that it says down over here, building. Okay, so it's in the process of doing all that compiling and stuff like that. So it's actually doing a lot of stuff we used to have to do step by step manually. So that's cool that we don't have to do that anymore. So now here's the connect, and here's the start. Okay, so those are the two things I need to do. So now my process is running. I'm driving a motor with a sinusoid, and so you can see how the output looks. Notice that these are large values because it's actually looking at encoder counts. Okay, it's not degrees, it's encoder counts. So that's That's what it has. And you can see it's a sinusoid with a little bit of a drift. It's kind of drifting downward a little bit. So there we have a successful run. And notice that the y data that variable I defined is now in the workspace over here. So we have successfully run a Simulink QuaRC model. Thanks for watching.